Hello my dear students, welcome to the lecture series of methods of differentiations, and this is our lecture number 3, and in this class we are going to discuss about the differentiation of inverse trigonometric functions. You see, differentiation of inverse trigonometric functions, and here we have two videos for the differentiation of inverse trigonometric functions, and this is part 1. So let us go through the video and concentrate to the class because this video is very important for you, and too much questions asked in your exam from this chapter. So please concentrate to the class to understand the problems of the chapter. So first of all, we need some problems of we need some formula for finding the derivative of inverse trigonometric functions. That is, the trigonometric functions you all already know that trigonometric functions are sin x, cos x, tan x, cot x, sec x, cosec x. These are trigonometric functions. And inverse trigonometric functions are sin inverse x, cos inverse x, tan inverse x. Those are inverse trigonometric functions. This one is sin inverse x. Y is equal to sin inverse x. Then the derivative of sin inverse x is 1 by root over of 1 minus x square, and where x should belongs to the open interval minus 1 1. You should not take here closed interval minus 1 1, because in those cases this is 1 by root over 1 minus 1 square will be there, because if you take the closed interval minus 1 1, then 1 can be included, and in case it will be 1 minus 1 0. So therefore this x should belongs to the interval minus 1 1. So this is y is equal to sin inverse x, then dy dx is equal to 1 by root over 1 minus x square. And how this derivative is equal to 1 by root over 1 minus x square, I will prove that one in the next screen. So before that, first I am just writing the formula of the differentiation of inverse trigonometric functions. This is the derivative formula for sin inverse x, and similarly this is the derivative formula for cos inverse x. Y is equal to cos inverse x, then dy dx is equal to minus 1 by root over 1 minus x square, and everything is same with the derivative of sin inverse x. Just there is a difference of negative sign. Okay, so then number 3, y is equal to tan inverse x, then the derivative is dy dx equals, the result is 1 by 1 plus x square, and where x belongs to the set of real numbers, because here x can take any value, so therefore x belongs to R. The number 4, y is equal to cot inverse x, then dy dx is equal to, the result is similar with tan inverse x, but a negative sign only here, and everything is similar to the derivative of tan inverse x. Okay, so the number 5, ddx of this sec inverse x is equal to 1 by x into root over 1 minus x square, and where mod x greater than 1, mod x greater than 1 mean x greater than, you know that one, mod x greater than 1 mean x this is greater than 1 and x this is less than minus 1, you know this one. Both of these two condition is included here. This is mod x greater than 1 mean x greater than 1 and x less than minus 1. Those values of x can be taken here. Other values of x, if you take here, that will be undefined. Okay, so ddx of sec inverse x is equal to 1 by x into root over x square minus 1. And finally y is equal to cosec inverse x, this is cosec, CSC, you may write cosec, COSEC. But in computer, cosec function is not written there, it is only cosec, CSC is written there. So y is equal to cosec inverse x is implies dy dx is equal to, the result is similar with the derivative of sec inverse x, but there is a negative sign here. Okay, so just you have to memorize 3 formulae here, is not it? You have to memorize 3 formulae. So what are the three formulae? The first one, derivative of sine inverse is this one, derivative of tan inverse is this one, derivative of sec inverse is this one, and the remaining three, sine inverse derivative is this, then cos inverse derivative is same with sine, just a negative there, then tan inverse derivative is this one, cot inverse derivative is similar to this, but there is a negative sign here, then derivative of sec inverse x is this one, and derivative of cosec inverse x is the same, but there is a negative sign. So I told you in the first year classes that derivative of any trigonometric or inverse trigonometric functions are negative, which are begin with the letter C. You know that one. I am writing here. This one, you know, derivative of cos in the first year, derivative of cos function derivative, it was negative, is not it? Cot function derivative, it was also negative. What is the result? You know that one, but negative I am taking about the sign only. And cosec inverse, cosec function derivative, it was also negative. In the similar manner, cos inverse derivative is negative. Then cot inverse function derivative is also negative, and cosec inverse derivative, this is also negative. So actually I am telling you that trigonometric and inverse trigonometric functions, derivative of trigonometric or inverse trigonometric functions, they are negative if they are beginning with the letter C. Okay, for easy memorization you have to follow this rule, that if a function, trigonometric function or inverse trigonometric functions, are beginning with the letter C, then the derivative will be negative. But you have to memorize the result, because the result is similar to the sine inverse, is similar to cos inverse, tan inverse similar cot inverse, sec inverse similar cosec inverse. Just you have to give a negative sign. Okay, so now I am going to prove these results, and you see sincerely here. Okay, so you see the proof of the number 1. So y is equal to sine inverse x was our function, and we have no formula for sine inverse x till now, but I can write this sine inverse. If you write here, then it is sine y will be equal to x. Very simple. It is the concept of inverse function will be discussed in the chapter inverse function. You have a chapter inverse function. There we will discuss about functions, inverse functions, and you have also a chapter inverse trigonometric functions. You have a chapter inverse trigonometric function. There we will discuss in details the properties, the formulae of some inverse functions, inverse trigonometric functions. So here I will give you the formulae. If you need some formulae in solution of the problems, then there I will give you the formula as a side note. So this is your y is equal to sine inverse x, then sine y will be equal to x. Now this is an implicit function, and already we know the differentiation process of implicit function. So differentiating with respect to x, you see the left hand side, it is sine y, and the differentiation is cos y, and for y it is dy dx only. So it is differentiation, sine y derivative is cos y, for y it is dy dx equals, right side is x, and x derivative of with respect to x is equal to 1, then dy dx will be equal to 1 by this cos y will be the denominator here, 1 by cos y. This is the result, but this y should be removed by x, and so cos y is nothing but root over 1 minus sine square y. You know this one. Then it is equal to 1 by root over 1 minus this sine y is x, so sine square y will be equal to x square, and that is the derivative. Dy dx is equal to 1 by root over 1 minus x square, and x should belongs to minus 1 1. Okay, so this is the derivative of sine inverse x, and now you can solve the derivative, you can find the derivative, and you can prove the formula for the derivative of cos inverse x. It will be cos y is equal to x, so derivative of cos is minus sin y dy dx is equal to 1. Dy dx will be equal to minus 1 by sin y, then minus 1 by sin y is equal to root over 1 minus cos square y, sorry, yes, 1 by cos square y, and then cos y is replaced by x, and that will be the result for derivative of cos inverse x. And you can solve yourself that one, and I am going to the proof of third one. Second proof you can do yourself by the same method, and I am going to the proof of the tan inverse x. So y is equal to tan inverse x, so tan y will be equal to x, then derivative of tan y is, it is differentiating with respect to x, it is implicit function, so tan y derivative is sec square y, you know that one, so it is sec square y, and y it is dy dx is equal right side 1 x, so derivative is 1, so dy dx will be equal to 1 by sec square y. Again you have to convert this y in terms of x, so it is 1 by sec square y is 1 plus tan square y, you know that one, is equal to 1 by 1 plus this tan y is equal to x, so tan square y will be x square, and x is belongs to r, and that is the derivative of tan inverse x, and this is the proof, simple proof. So you can find the derivative of cot inverse x, it is cot inverse x, then cot y is equal to x, cot y function derivative is minus cosec square y dy dx equal to 1, so dy dx will be equal to minus 1 by cosec square y, then is equal to minus 1 by cosec square y is written as 1 plus cot square y, and in place of cot you write x, that will be the result for cot inverse x. Okay, so then you take the proof of the fifth one, this one, y is equal to sec inverse x, so sec y is equal to x, differentiate it because now it is an implicit function, so differentiating with respect to x, sec y function derivative you recall it, it is sec y into tan y, then for y you are to write dy dx, this one sec y tan y, then for y it is dy dx, right side x, so will be equal to 1, then implies dy dx is equal to this will go as denominator of 1, so it is 1 by sec y tan y is equal to 1 by sec y is has the value x already, so sec y remaining same, and tan y can be written as root over sec square y minus 1 by trigonometric identity only. Okay, then again sec y is replaced by x here, so it is x into root over this one x square minus 1, and here is the condition. These conditions will be discussed in details in the chapter inverse trigonometric function. Okay, so this is the result for the differentiation of sec inverse y, sec inverse x. Okay, then you can solve the number 6 one, because in that it is cosec inverse y, then cosec y is equal to x, cosec y derivative is minus cosec y into cot y, then into dy dx is equal to 1, then it is minus 1 by cosec y cot y is equal to 1 by, minus will be there, cosec y remaining same, but cot y is root over cosec square y minus 1, then cosec y replaced by x will be the result, only difference is negative there. Okay, so I think you can solve the rest of the 3, mean 2, 4 and 6, you solve the 3 proofs yourself. Okay, so now I am going to the problem section of the chapter inverse trigonometric functions. So before that we have some special substitutions for x. Substitutions, this means a replacement for x. In some problems, for our convenience, we take substitutions for x. You see a table here. This is a special substitution table. You see that is these are terms, this column is terms, and these are the corresponding substitutions for the terms. Say if in a problem inside sine inverse or inside cos inverse, inside tan inverse and so on, inside some inverse trigonometric functions, if we have these types of terms, that is terms containing of the form a square minus x square or a square plus x square or x square minus a square, these types of terms, or this is one special kind of terms I will discuss later on. But if inside a trigonometric inverse trigonometric functions there are these types of terms present, then we take the replacement for x as given in this table. If the terms contains like a square minus x square terms, a square mean it is a constant number, that is it may be 1 minus x square, it may be 2 square mean 4 minus x square, 9 minus x square, that means it is a constant number minus x square. In all cases we are to take the replacement for x or substitution for x as x is equal to a sin theta, or you may take x is equal to a cos theta, but in general we take x is equal to a sin theta, this one. Why we take x is equal to a sin theta in this case? Because you see here, if we take x is equal to a sin theta in place of x, then this term will be a square sin square theta. Then the total term is a square minus a square sin square theta. Then a square can be taken common, so the term remaining inside the bracket will be 1 minus sin square theta, and 1 minus sin square theta will convert it to cos square theta. That means the final term will be a square cos square theta. So this double term, there are two terms now, but after taking this substitution, this term will convert it to a single and simplified term. In the similar manner, if inside an inverse trigonometric functions with these types of terms a square plus x square, then we take x is equal to a tan theta, or you may take x is equal to a cot theta also. Generally we apply x is equal to a tan theta. So here using a tan theta will be is equal to here a square plus a square tan square theta. Then a square can be taken common, here 1 plus tan square theta will be there, and 1 plus tan square theta is equal to sec square theta. Similarly, in these types of term x square minus a square, keep in mind this a square is a constant number, okay, a square is a constant number. So x square minus a square, in that case x is equal to a sec theta you take, so it will be a square sec square theta minus a square is common, so sec square theta minus 1, and sec square theta minus 1 is equal to tan square theta, and from there we can simplify the entire term to a simple form, and then we can differentiate the term. And you see, if this types of term is present, interestingly this square root sign is necessary here, okay, this square root sign is necessary. Without this square root sign you should not apply this substitution, so square root sign is necessary. Here this plus minus, these two signs, plus may be in the denominator or in the numerator, there may be negative, and it may be reciprocal of this one, like this a plus a to the power k plus x to the power k, a to the power k minus x to the power k, mean this term may be the denominator and this term may be the numerator, that is no matter, that is not a matter. Just you should keep in mind this k is a constant number, it may be cube, it may be square, it may be 1, anything in place of k, it may be a fractional number also, okay. So k is a constant number, a is already a constant, x is the variable only. So in all the cases, in all of that cases where these both terms are present at a time with positive and with negative, like this, either in the numerator positive sign, denominator negative, or numerator negative, denominator positive, in between the two terms, that is not a matter. So but these both terms should be present at a time. As well, this square root sign is also present, and these terms should be inside in an inverse trigonometric function. In all cases the substitution is taken as x to the power k, mean this term is equal to a power k cos 2 theta. because if you take this a power k cos 2 theta here in this place, so a power k will be common, it is 1 minus cos 2 theta, and here a power k will be common, 1 plus cos 2 theta, as like here also. So a power k in the numerator and denominator, after taking common, this term will cancelled out. So here only 1 minus cos 2 theta and 1 plus cos 2 theta will remain. And 1 minus cos 2 theta has a formula, and 1 plus cos 2 theta has also a formula. 1 minus cos 2 theta you should replace by 2 sin square theta, and 1 plus cos 2 theta you should replace by 2 cos square theta. And after simplifying this, we will get a simple term, and from there you can differentiate the term very easily. Okay, so that is why we take this particular substitutions here. Okay, so now we go to the problem section of the chapter. So first question, find dy dx where y is equal to this one. Y is equal to this one. If y is not given here, just x sin inverse x plus root over 1 minus x square is given, and the question is asking for find derivative, then you take let y is equal to this one. মানে যদি এইখিনি বস্তু কেৱল দিয়া থাকে আৰু যদি কয় যে ডেৰিভেটিভ নিৰ্ণয় কৰা, তেতিয়াহলে তুমি প্ৰথমে লিখিব লাগিব let y is equal to this one. ওকে, তাৰমানে আসামিছত কিছুমান ষ্টুডেন্টে বিচাৰিছে, তো মোৰ অলপ অসুবিধা হয় কাৰণে তেওঁলোকক কৈছো, যদিও মই অলপ ইউজ কৰিবলৈ ট্ৰাই কৰিছো, যদি আসামিছত দৰকাৰ পৰে তেওঁলোকে অলপ হেল্প পাব, সেই কাৰণে মই অলপ আসামিছ কৈছো. Okay, so y is equal to x sin inverse x plus root over 1 minus x square. So find the differentiation. It is dy dx is equal to, it is a product function x into sin inverse x. So product function, first derivative of x is 1, sin inverse x remaining same, plus then x is remaining same here you see, and derivative of sin inverse x has the formula 1 by root over 1 minus x square, just obtained in the previous screens. Then it is the differentiation of x sin inverse x, then plus, now you come to this part, root over 1 minus x square. So first differentiation of root over, that is 1 by 2 root over, the inner part will remain same here because 1 minus x square is considering as x here, so it is 1 by 2 root over as like x, into then this 1 minus x square derivative is simply 1 is 0 minus x square derivative is only 2x minus 2x only. Then simplify this 2 and 2 will cancel, dy dx will be equal to sin inverse x remaining same, then it is plus x by this one, minus will come out, this 2 to cancel, so x by root over 1 minus x square is this. This term and this term are same, positive negative cancel, so we have only sin inverse x is the derivative of this function. Okay, so very simple question is this one. And then you take the next question, y is equal to tan inverse of root over 1 plus x square minus 1 divided by x. This is our problem. Now in this question, if you use the direct formula for tan inverse x, the result will come out. The direct result mean, if you write like this, you see here, you see like this, you see dy dx is equal to, if you write dy dx directly, dy dx is equal to this tan inverse function. So tan inverse function derivative is 1 by 1 plus x square. X is what? X is this total part, 1 plus x square, then minus 1 whole terms divided by x, this total term square will be there, 1 plus x square. This is the derivative formula for tan inverse x, into this term is considering as x, so ddx of that term will remain in there as per the chain rule. Okay, ddx of this part remaining there, root over 1 plus x square and divided by x as like. But this calculation will be very tougher, you see, very tougher, because ddx of d dx of here will be root over 1 plus x square minus 1 divided by x. Root over function derivative in the numerator 1 by 2 root over, that means the calculation will be very heavy. So we should not use that method here. I am erasing this. We should not use the method here. You can use the method, but it will be very tougher than the method I am going to use now, that is by substitutions. In the previous screen, we just discussed about the substitution, special substitutions. And here you think, what is the substitutions? You see the table just written. You see the table just written in the previous screen. What will be the substitution for x here? আমি x or হলনি কি লব লাগিব তুমি সেই টেবুলখন চোৱাচোন তাতে তুমি চাবা we have a term like this. We have a term like a square plus x square. এনেকুৱা এটা আছিল নে মন কৰি চোৱা. And here it is a square mean 1 plus x square like this. এটো লগত মিলি গৈছে 1 plus x square. So a square plus x square substitution was this a square plus x square substitution কি আছিল a tan theta. It was a tan theta. And here a should be equal to 1. So we are to take only tan theta. Very simple. We are to take only tan theta. আমি মাত্র tan theta use করলে হবো. Is that clear? So I am going to take the substitution as tan theta. You see here, let x is equal to tan theta, then theta will be equal to tan inverse x, because at the last part of the function you should again replace theta by x. After that you find the derivative. Okay. So y is equal to tan inverse is remaining same. It is root over 1 plus tan square theta minus 1 divided by tan theta is equal to tan inverse. This 1 plus tan square is sec square and root over sec square is only sec theta minus 1 divided by tan theta. Simplify more. Tan inverse is remaining there. Sec theta is equal to 1 by cos theta minus 1. Tan theta is sin theta by cos theta. Take LCM cos theta in the numerator and denominator. So if you take cos theta in the numerator and denominator cos theta is already there, will be cancelled. So only term remaining is 1 minus here will be cos theta and therefore divided by sin theta is there. Then cos theta will be cancelled. I am skipping that line here. Then the next one, tan inverse of, it has the formula 1 minus cos theta, then 2 sin square, half of this angle, it is simply theta by 2. And considering this sin 2 into theta by 2 like that, then it is sin 2 theta formula, 2 sin theta by 2 into cos theta by 2. Sin, one of the sin theta by 2 will cancel, 2 is cancelled. So it will have only sin theta by 2 by cos theta by 2, and that is simply tan theta by 2. It is tan theta by 2. And tan inverse and tan will cancel out, only theta by 2. And then derivative of theta by 2 and use the result for theta. And this is implying y is equal to theta result is tan inverse x here. You see half is remaining there, half tan inverse x. Okay, so now find the derivative. So implies dy dx is equal to half remaining same, and tan inverse x function derivative is 1 by 1 plus x square, and this is your result. Okay, so this calculation is very simple. So therefore we are taking here this method, not the direct method, because in this case the direct method will be very heavy calculations there. So this completes the solution. Okay, so next we take another question, number 3. Y is equal to sec inverse 1 by 2x square minus 1. And actually in the chapter inverse trigonometric function we will discuss in details about the properties of inverse trigonometric functions. So inverse trigonometric sector to আমি property বিলাক details discussion কৰিম. So ইয়াতে আমাৰ এটা ফৰ্মুলা পাম actually, তাৰ মানে এনেকুৱা এটা ফৰ্মুলা যে ধৰা তোমাৰ cosec ইনভার্স x আছে তোমাৰ, তেতিয়াহ'লে এইটোক মই যদি sin ইনভার্স লিখো, এটা ফর্মুলা এটো sin inverse লিখিলে তুমি এই টার্মটোৰ for this term you write the reciprocal only sin inverse লিখিলে এটো যদি মই sin inverse লিখো তেতিয়াহলে inside যেটো টার্ম that term should be written in reciprocal form 1/x তেনেকুৱাকে if you have a sin inverse x function then if you want to write cosec inverse then you are to write 1/x inside that তেনেকুৱাকে sec inverse x আছে you can write cos inverse 1/x বা cos inverse x আছে you can write sec inverse 1/x মানে inside term to তুমি reciprocal লিখিব লাগে that is the concept actually okay inside term to তুমি reciprocal লিখিব লাগে আৰু forward function কি কৰিব লাগে outer function to reciprocal হয় যেনেকুৱাকে sin theta is equal to 1/cosec theta এটা তো জানা তোমালোকে কিন্তু ইয়াতে cosec inverse লিখিলে inside term to তুমি reciprocal লিখাব লাগিব so that theorem is applying here আৰু হেতুৰ বিষয়ে তুমি ডিটেইলছ শিকিব পাৰিবা in the chapter inverse trigonometric functions here you just write here you have the formula this sec inverse x formula sec inverse x this is equal to if you want to write cos here then it is cos inverse of what 1/x so here we are going to use this theory so here ki ahibo y is equal to sec inverse 1/2x square minus 1 so cos inverse it is simply 2x square minus 1 using this one okay just writing the reciprocal of this I am erasing this okay so now you can use the derivative of cos inverse x function directly here by considering x this one mean cos inverse function derivative was minus 1/√1 minus x square is this whole square okay then ddx of again derivative of this one and if you simplify that you will get the result but here I am not taking that method I will use a substitution here and here it has a special substitution not a general substitution and that is why I have not written that substitution in your table my table to a substitution to likha nai karon table to jikata likhisu heketa hoise general substitution but here it is an special substitution special mean tumi just চিন্তা কৰা যে x or place of trigonometry কোনটো বস্তু ইউজ কৰিলে ফৰ্মুলা হ'ব just হেতু চিন্তা কৰিলে হ'ব just think about which trigonometric angle you should use in place of x here to get a formula is it not cos theta if you take x is equal to cos theta here if you take x is equal to cos theta then it will be 2 cos square theta minus 1 and we have a formula for 2 cos square theta minus 1 and the formula is cos 2 theta so I am going to use that way and that way will be easier than this way okay so I am taking x is equal to cos theta so theta will be equal to cos inverse x and use this result in place of x here so therefore y is equal to cos inverse of 2 cos square theta minus 1 is remaining there and cos inverse 2 cos square theta minus 1 is simply cos 2 theta then inverse and forward function will eliminate each other it is simply 2 theta actually there are some conditions also but here if any conditions are not given in the problem then you should consider the principal branch and those topics will be details discussed in the chapter inverse trigonometric function but here if no conditions are given you should consider the principal branch so here nothing condition given on x so I am going to use the principal branch but if certain conditions of x given here then you are to verify before removing this inverse and forward function so মই কব খুজিছো যে যদি x ৰ ওপৰত কিবা পাৰ্টিকুলাৰ কন্ডিশনস ইয়াতে দিয়া থাকে তেতিয়ালে মই কিন্তু এই বস্তুটো ডাইৰেক্ট ৰিমুভ কৰিব নোৱাৰো ইন দ্যাট কেস মই সেই কন্ডিশনসটোৰ ওপৰত বেস কৰি ইয়াতে চাব লাগিব আৰু সেই মতে হে এই ৰিমুভেশনটো আহিব আৰু সেই কথাবিলাক ডিটেইলস ডিসকাশন হ'ব ইন ইনভার্স trigonometric functions so here no conditions are given on x x এর উপরত কোনো কন্ডিশন মোক দিয়া নাই, that is why I am going to use the principal branch, and in principal branch always this can be removed directly. তো এইটো মই ডাইরেক্ট রিমুভ কৰিছো, 2 থিটা হৈ যাব। Okay, then replace theta with its value. Theta is cos inverse x, so here use cos inverse x. So finally y will be equal to 2 is there, and it is cos inverse x. Now we have formula for cos inverse x derivative. So dy dx is equal to 2 into cos inverse function derivative is minus 1 by root over 1 minus x square. So it is simply minus 2 by this, and that is the completion of the problem. Next, number 4, y is equal to tan inverse 1 plus x by 1 minus x. No doubt here again you can use the direct formula dy dx of tan inverse, considering this total function as x. So that will be, what is the formula you see? Formula to ki asile? Formula to asile enakwa etu tahibo tumar 1 by 1 plus, in place of x is 1 plus x divided by 1 minus x, this total part whole square, okay, and into ddx of this, aru hekhini tumi quotient rule logai pelai korile hoi jabo. This part you just use the quotient rule, simplify kori dia ahi jabo answer, okay. So use kori diom moi, etu korile hobo kintu, but I am, you see here, moi hetu method use korisu, but you can use x is equal to hetut nahibo de, eta root over thakile ahile heten, if it is square root 1 plus x square 1 minus x square etu thakile ahile heten, etu direct result hoibo 1 by 1 plus this term is square into quotient form ekhine derivative ahibo, so 1 minus x whole square, then 1 minus x remaining same, derivative of 1 plus x is simply 1 because 1 is 0, x is 1, then compulsory minus 1 plus x is there, derivative of 1 is 0 and minus x is minus 1. So complete the product, taking LCM here, 1 minus x square is LCM, that is going to the numerator, 1 minus x whole square, this is plus 1 plus x whole square, and this denominator is going to the numerator into, and here 1 minus x and this is 1 plus x, minus plus x is cancelled, 2 will be there, this whole square. Now this term and this term is cancelled, so it is 2 by this term, it is a minus b whole square plus a plus b whole square, has the formula 2 times of a square plus b square, that is 1 plus x square. So this 2 and 2 is cancelled, simply 1 by 1 plus x square. So that is the answer for the question, and this is your alternative method. We have a formula in the inverse trigonometric function that tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. That has a formula. If this is minus, then the numerator will be plus. Numerator will be minus. Denominator is plus. And here it is plus, so numerator plus, denominator is minus. So formula is simple. Tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. So if you use this method here, you may use this method by using this formula of inverse trigonometric function. This is a formula, okay. So this will be discussed in the chapter inverse trigonometric function, and you see y is equal to tan inverse 1 plus x by 1 minus x is equal to, you can write it 1 plus x divided by 1 minus 1 into x. Is it clear? 1 into x, that is x plus y divided by 1 minus x into y. It will like that. So it is simply tan inverse first one plus tan inverse second one, and tan inverse 1, this result is pi by 4, you know, that is this is a constant term actually. So dy dx, this is constant term, pi by 4 will be 0, need not to write there, and tan inverse x function derivative is 1 by 1 plus x square. So you may use this method also, okay. Now y is equal to sec of tan inverse x. Here you do not use direct method, you should use the substitution method, because now this term you should try to write this inner function tan inverse in terms of sec inverse, because in that case sec of sec inverse something will be there, sec of sec inverse will remove each other, so something will be remain there, then find the derivative. This is the easier way. So in these types of problem you do not use direct formula for sec functions. Okay, actually you can write like this, but that is not the method actually. This is sec of tan inverse x into tan of tan inverse x into ddx of tan inverse x is 1 by 1 plus x square. Then simplify it. This may be one of the method, but it is not suitable method actually. Okay, it is not suitable, even comfortable nohoy, dekha to bhal na lage. So in these types of problem you always try to convert this inverse term in terms of this outer term tan inverse, so you should convert tan inverse in terms of sec inverse, so that sec and sec inverse remove each other. Okay, for that we have a technique here. You see this one, you just take this tan inverse x is equal to theta. Okay, tan inverse x is equal to theta, so tan theta will be equal to x, and tan theta is equal to we know this one, tan theta in case of right angle triangle, tan theta is equal to perpendicular by base, and here tan theta is equal to x, x mean actually x by 1, so here the perpendicular is x and base is 1. This is the shortcut technique actually. So x by 1, the perpendicular is x, base is 1, so we can find the hypotenuse, and that is root over x square plus 1, this one. Okay, so tan theta is equal to this x, so this is the hypotenuse. So in that case what will be sec theta? Tan theta is this, so sec theta is what? Sec theta is inverse of cos, and cos theta is base by hypotenuse, you know that one, that is cos theta will be equal to 1 by root over 1 plus x square. So sec theta will be root over 1 plus x square by 1, that is simply root over 1 plus x square, this is here. So theta will be sec inverse of root over 1 plus x square, but theta was what? Theta was tan inverse x, so tan inverse x is equal to sec inverse root over 1 plus x square. So very simple method actually. So now in place of this tan inverse x, now you can write sec inverse 1 plus x square. So I am writing there. So sec inverse root over 1 plus x square. Now this can be removed. This can be removed. It is simply root over 1 plus x square. Now differentiate. It is easy. Dy dx is equal to 1 by 2 root over 1 plus x square. Then 1 plus x square derivative is twice x. 2 cancel, and that is the result for the question. You picked my point? মনত ৰাখিবা কিন্তু এইখিনি বস্তু টেকনিক যেটো টাৰ্মস লাগে ইয়াতে ট্ৰায়াঙ্গলটো কমপ্লিট কৰাৰ পিছত তোমাক tan লাগে sec লাগে cot লাগে cosec লাগে সবখিনি ইয়াতে পাবা কাৰণ আমি জানো নহয় sin θ মানে পারপেন্ডিকুলার বাই হাইপোটেনাস cos হলে a2 বাই a2 tan হলে a2 বাই a2 cosec হলে ইনভার্স অফ sin মানে সাইনৰ ক্ষেত্ৰত a2 বাই a2 তো cosecৰ ক্ষেত্ৰত a2 বাই a2 হ'ব তেনেকুৱা কথা সো you just observe the outer function, and about the outer function you convert this inner function in terms of the inverse of outer function. Okay, so heneke convert kori result koriba. So that is the result, and then you take the next question. Y is equal to tan inverse sec x plus tan x. Do not use direct formula here. Again some calculations are there, and after taking the calculations you find the derivative. Okay, so tan inverse of this is 1 by cos x sin x by cos x. Very simple. By taking LCM, 1 plus sin x by cos x. Tan inverse, it is 1 plus sin x is nothing but cos x by 2 plus sin x by 2 whole square. Why it is equal to this? You see here. Because this 1 can be replaced by cos square cos square x by 2 plus sin square x by 2 1 or place of it likhilo, then plus sin x, it can be considered as sin twice x, so 2 sin x by 2 into cos, writing khini bhalo anai dei, cos x by 2 karon pen thakile bhalo holeten, pen nohoy to moi mouse di kori asu. So you see this term, এইখিনি চাব, এইখিনি বুজিব পাৰিছা না? সো ইয়াতে এই 1 প্লাস sin x এই টার্মটা চাব, 1 অর প্লেসত মই লিখিলো এইখিনি 1 প্লাস sin 1 is equal to cos square x by 2 plus sin square x by 2 and sin twice x consider করে লিখিলো মই 2 sin x by 2 plus cos x by 2 and now it is of the form a square plus b square plus twice ab and so it is a plus b whole square, that is cos x by 2 plus sin x by 2 whole square. So you got my point? So 1 plus sin x is equal to cos x by 2 plus sin x by 2 whole square. Okay, and this is cos twice x formula. This is cos twice x formula. So it is simply cos square x by 2 minus sin square x by 2. Okay, minus sin square x by 2. This 2 into x by 2, consider that one, 2 into x by 2. So cos square x by 2 minus sin square x by 2. So then tan inverse of one of the terms will be cancelled because cos square x by 2 minus sin square x by 2, it is equal to cos x by 2 plus sin x by 2 and cos x by 2 minus sin x by 2. So plus term will cancelled, so whole square will be this one, and here one of the factor remaining, that is cos x by 2 minus sin x by 2, this factor is remaining, and there is, you see here, erasing, I am erasing this, sorry, this one, you see this, one of the factor is cancelled because cos x by 2 plus sin x by 2 will cancelled and cos x by 2 minus sin x by 2 remaining there is equal to, dividing by cos in the numerator and denominator, it is 1 plus tan x by 2 divided by 1 minus tan x by 2 is equal to tan inverse of, you see it is 10 pi by 4, 1 is equal to 10 pi by 4 and here 1 minus 1 into tan x by 2 and 1 is equal to again 10 pi by 4. বুজি পাইছা না কথাটো মই কি কৈছো? actually এনেকুৱা হৈ আছে মোৰ বস্তুটো, 1 অৰ প্লেসত তুমি লিখিব লাগে 10 pi by 4, 1 অৰ প্লেসত লিখিব লাগে 10 pi by 4 প্লাস এটো তো 10x by 2 আছে অলরেডি, আর ডিভাইডেড বাই 1 মাইনাস আর ইয়াতে 10 pi by 4 এটা ভাবি লব পারে, বুঝি পাইছা না কথাটো, 10 pi by 4 into 10x by 2 তো অলরেডি আছে, এই ফর্মুলাটোৰ কথা মই কৈছো, এটোৰ কথা মই কৈছো, 10 pi by 4 এই ভিতৰখিনি, this is 10a plus 10b divided by 1 minus 10a into 10b formula আছে, তো it is simply 10 of a plus b formula, তো হেতু লিখিলো 10 pi by 4 plus 10x by 2 আৰু হেতু এতিয়া তুমি ৰিমুভ কৰিব পাৰা, এটো তুমি ৰিমুভ কৰিব পাৰা ইনভার্সৰ এটো, so that is removed, simply pi by 4 plus x by 2 is there, so dy dx is equal to 1 by 2 because pi by 4 is 0 and x by 2, x derivative is 1. Okay, so then the next question, y is equal to sin inverse this one, and here though a square minus x square is present there, but if you take a sin theta here, it is cos square theta, it is sin square theta, the final result will be 10 square theta and root over 10 square is 10, but outer function is sin inverse 10 theta cannot be removed, That is why we are not taking here substitution, just direct differentiation is taking here. So dy dx is equal to 1 by sin inverse function 1 by root over of 1 minus this square, and root over is cancelled here, this one, actually root over x square by a square minus x square whole square, and that is simply this one. It is the derivative of sin inverse function, then into now this inner function derivative root over function, that is 1 by 2 root over, the terms remaining same. Now again differentiation of this inner part, x square by a square minus a square, this inner part, into use the quotient rule, denominator whole square, then denominator into derivative of x square is 2x minus x square remaining same, derivative of denominator is minus twice x because a is constant. Simplify it only, simple. So LCM a square minus x square is LCM. This root over a square minus x square will go to the numerator here. So it is a square minus x square and this minus x square into 2 times of root over x square is x only, and this term root a square minus x square will go to the numerator, into here twice x cube is cancelled here, twice x cube negative, twice x cube positive is cancelled, so twice x into a square remaining there, 2x is cancelled, and here root over a square minus x square double term, so it is simply a square minus x square, 2x is already cancelled, a square remaining there, this is a square minus twice x square into this term a square minus x square whole square, one of the term a square minus x square cancel, so simply a square by this is remaining same, this is remaining same, and that is the answer for the question. And this question is homework for you. Use this rule, simple. Y is equal to sin inverse of a sin x plus b divided by a plus b sin x. I am going to solve this. Use direct method. Dy dx is equal to 1 by 1 minus, consider this is x, so whole term square, into ddx of this part, that is denominator is square, denominator into ddx of numerator, it is a remaining same, and cos x, sin x derivative is cos x, b is Allen constant 0, minus, now numerator into a sin x plus b into derivative of this denominator, this one, a is 0 and b remaining same, sin x derivative is cos x, b cos x. Simplify it. LCM is a plus b sin x whole square, and whole square will come out of the root over sign. It is simply a plus b sin x will go to the numerator. It is a plus b, actually a plus b whole square is the LCM, but it is under radical sign, and if you take the term out of the radical sign, that will go to the numerator without the square sign, okay. And here a plus b whole square minus a sin x plus b whole square into, and here just simplifying, it is ab sin x cos x, and here ab sin x cos x negative positive cancel, so it is a square cos x, and here minus b square sin x cos x remaining there. So cos x is common, a square minus b square remaining there, one of the term this is cancelled, so a square minus b square, this cos x is remaining, and here is you sincerely this see this, after completion of the square term, twice ab sin x and here minus twice ab sin x will cancel, and then a square common from this term 1 and from this term sin square remaining, minus b square common from this term 1 and minus sin square is there, into 1 by this is remaining because one of the a plus b sin x is cancelled. Then a square minus b square cos x is there, it is 1 minus sin square x is common, that is cos square x, and if you take that cos square x out of the this root over sign will be cos x, so it is cos x, and inside is a square minus b square remaining, this term is remaining same, cos x is cancelled, root over a square minus b square is there because this term and this term can be cancelled by taking root over of a square minus b square whole square, one of the term is cancelled, cos is direct cancel, and a plus b sin x is remaining there, and this is the solution for the question. And this is for this is the homework for you, sin inverse function directly use, and this is root over function. you can solve this problem. And this is the end of our class, and you solve the homeworks and show me. So in the next part we will discuss the problems, more problems of this chapter, and that will be the last video for the derivative of inverse trigonometric function. So till then, thank you very much.